Hi, this is part 2 of my video on the notes for today, the second part of 2.2. So I'm going back to the guided notes. In the first video, I finished by doing some examples of finding areas under the standard normal curve. Let's do a couple that aren't standard normal, and that's the beauty of this technology and not having to go to table A in the book, or as you'll see in Khan Academy, use a table of z-scores and standardizing. So here are the same problems you have in your guided notes. They're also the same ones from the PowerPoint. Some of them are. I think I just added a few additional ones. So the distribution of these test scores, same kids in Gary, Indiana, we've been talking about for 2 days. This distribution is normal with a mean of 6.84 and a standard deviation of 1.55. And in question 1, I'm asked, what proportion of these 7th graders have vocab scores that are below 6th grade level? So it's really the question we wanted to answer in the notes first of all before I went back to standard normal. Well, anyway, let's draw our curve. Again, sorry, I'm using my fingertip to draw it here. So here's my normal curve. I put the mean in the middle, so 6.84 is in the middle. And I'm going to go ahead and write the mean over here as well. The mu, we were told, is 6.84. And the standard deviation is 1.55. I'll need that for my calculations in a second. All right, so I want to know what proportion are less than below 6th grade level. Well, the mean level of these kids is 6.84. Now let's talk about what that means for a second. This mean means that these kids on average are scoring at the 6.8 grade level. So almost at grade level, just slightly below. So I want to know, well, what about 6th grade level or below? So I label 6. Below means I shade down here to the left. And the beautiful thing about technology is I don't have to standardize. I don't have to use the z-score formula. Khan Academy, again, is going to show you using the z-score formula. We don't really need that. So let me go to my calculator. Again, if you're at home, you're using the 84 or Calculate 84, the app. It works the same way. I go to second VAERS, norm CDF, that number 2. We'll never use option 1 there. So I look at my picture. So I'm over here at my picture. The furthest left my shading goes is forever, negative infinity, right? This curve gets infinitely close. So I'm going to go ahead and put negative George Sink, all 9s. My upper bound is how far right the shading goes. So my shading stops at 6. And then the mean, we're not standard now. Our mean now is 6.84. And our standard deviation is 1.55. And I go ahead down, paste. So 0.294. So the area here is 0.294. And let's talk about what that means for a second. I mentioned in the previous video, you can turn these into percents. Like if I move this decimal twice, that's 29.4%. So what I can say about these kids that in Gary, Indiana, 29.4% of these 7th graders in Gary, Indiana are scoring at the 6th grade level or below. So high, low, I mean, the gauge, I don't know who to compare it to, but it makes this problem make a little bit more sense. Let's do a couple more of these. I guess I do 2 and 3. So 2, what proportion, same people here, of 7th graders are above grade level? So 7th or above. So I draw my picture. I label my mean in the middle, 6.84. And then 7th or above, so I put 7 to the right because 7's bigger than 6.84. And I want to know above 7th. Now, a common question here is, well, do I include 7 or do I go to 8? No, we include 7. If you think back to these quantitative variables, this is one that's continuous, or normal distributions are what we call continuous, meaning there's infinite decimals here. So I need to get infinitely close to 7, and I can't really define infinitely close. So regardless if it says above, if it says equal in there, like 7th or above or just above, I'm still going to use whatever I label here as my lower bound or sometimes upper bound. All right, so back to my calculator, I go to second VAERS, pick option 2. My lower bound now is 7 because that's the furthest left my shading goes. My upper bound is George Sink because I'm going to the right forever. My mean and standard deviation are still in there from the last problem. I'm not sure if the phone app does that, so make sure you change them if you need to. So that's 0.459. So that area is 0.459. And again, feel free to make it a percent if you'd like. That just means move the decimal twice. So 45.9, or about 46% of these kids in Gary, Indiana are at grade level or above. Let me do one more and I'll let you you can do the last one on your own. So last one, what proportion of these 7th graders have vocab scores between 6 and 8? So I draw my picture, I label my mean. That was a pretty good one for me using my fingertips. All right, between 6 and 8. So 6 is a little bit to the left of the mean. 8's a little bit to the right of the mean. Doesn't have to be drawn to scale. And in between means I'm shading in here. So I go to my calculator, second VAERS, pick norm CDF. My lower bound now, go back to my picture. The furthest left the shading goes over here is 6. The furthest right it goes is 8. And same problem, so I'm at the same mean, same standard deviation. I get 0.479. So about 48%. I mean, again, you can kind of move this if you need to. 47.9% of these kids in Gary, Indiana, they scored between the 6th and the 8th grade level on this vocab test. I'm going to pause and go back to the PowerPoint. Got one more thing to go over. All right, the last thing we'll talk about today, again, this is in the guided notes. I think I have it typed up for you, this part, is working backwards. So what if we're given an area under the curve? What if we're given the shaded area and we're asked to find what value gives that area? Common problem will be percentiles. They may say, which value marks the 95th percentile? Well, that would mean on your curve, you would shade the whole curve, 95% of the curve from the left up to wherever you think 95% is, and you'd see, well, what value gives you that? So it's very common to want to work backwards. So my steps are here. Again, we're going to sketch a picture and label it. This time we're going to shade first and then put a variable where the unknown boundary value is. We're not going to use table A. We're going to use technology. So we're going to use a calculator again. So you'll need your TI-84 or your Calculate 84 app. All right, let me go back to the guided notes. I have a couple extra examples in there. And again, they're posted. So here in the guided notes, if they show up here, you can see here are the calculator steps we're going to follow. So similar to the other ones, again, here's how we'll do them in class in the Inspire, but if you're at home on an 84, we're still going to go second VAERS, but this time we're going to pick option 3, inverse norm. So that literally means we're doing the opposite. We're inverting the process we've done up until this point. So let's look at a couple standard normal first, and then we'll look at a couple applications. So here we're standard normal. Again, if you see standard normal, that just means it's a normal curve, that bell-shaped curve with a mean of 0 and a standard deviation of 1. So let's go ahead and start off like we did before. I'm going to sketch my curve. I'm going to label my 0 in the middle, but this time I'm told the left area is 0.25. So let's think about this. The whole area of the curve is 1. So if I want 0.25 of the area, that's going to be somewhere down here, less than half. Now, I don't know what this value is. I'm going to put an X there. You can call it Z because these are Z scores. But I want to know, what is this value that gives me this area of 0.25? So go to the calculator, similar process as we did before. I go to second VAERS. This time we pick inverse normal. Now it asks for area first. Now listen now, write it down, make a star. The calculator only understands left areas. So it only understands left shading. That's the bad thing about these calculators. Well, conveniently in this problem, I'm given a left area, right? This is the left side of the curve. So I'm given a left area, so I put in the 0.25. This guy is standard normal. So the Z-score that marks the bottom 25% or the 0.25 area, that Z-score, and I'm only using Z here because it's standard normal, That z-score that gives me that, I already forget what it is, negative 0.67. And rounding, we talked about in class, we round z-scores to 2 decimals typically. I'm not super picky. When we do the real life ones, sometimes you'll round to whatever the data looks like, the same as the mean, for example. All right, let me do a right area and show you how that works. So same standard normal. Oops, crazy looking x-axis, but here's my standard normal. But now I want the right area to be 0.45. So I look at the right side of the curve. Well, we know that half the curve is 0.5. So 0.45 on the right half is probably right about here. So that area is 0.45. I want to know, well, what z-score, what z-value gives me that area? Now again, the calculator will not understand right areas. So I got to use a little thinking. Well, if the right area is 0.45, that means this left area has to be 0.55. Right? We define these normal curves as having, or really any density curve has an area of 1. So my calculator, I'm going to go to second VAERS, pick inverse normal. I put in the left area, so I need 0.55. I'm standard, so I leave the mean as 0, standard deviation is 1. And I get 0.13. So a z-score of 0.13 gives me that area. And it makes sense, right? 0's here, so 0.13, that makes sense. Now let's do one more. Center area is 0.75. These are the tricky ones. So here's 0 in the middle. So I want my middle area to be 0.75. I'm just going to label it here. My calculator does not understand middle areas. It understands left areas. So I need to put in this area. Well, if this is 0.75, that means 0.25 is left over, and half, right? These two tails consist of 0.25, so that means this area has to be 0.125, if that makes sense. Again, I'm just manipulating things I know about the curve. I know the whole area is 1, so if 0.75 is accounted for, that means 0.25 is left over. I only want this guy, not both the tails, so that's 0.125. So I go to my calculator, second VAERS, go to inverse norm, 0.125, and I get a z-score of negative 1.15. And then I do the same thing for the other one. I know here because of symmetry that it's going to be the same, just positive, but I won't in all cases. So if I really want this z right here, if I want this guy, I have to take this entire left area. Well, this entire left area is going to be what? 0.99, or let me see, sorry, real quick. 0.975, I believe. So 0.975, I go back to inverse norm. Second VAERS, 0.975. That second z value, oops, I messed up, hold on. 0.125 and 0.75. Oh, 0.875. Oh, Lord. It's Friday, y'all. Let me go ahead and just change this to 0.875. And there I get that 1.15 that I wanted. So this z is 1.15. Now I'm running out of time on my video. I only get 15 minutes max. So the other examples, try them on your own. If you still don't get them, just shoot me an email, but they work the same. The difference is you have a different mean here. So you're going to have to change the mean and change the standard deviation in your inverse normal. But the process is the same. So go ahead, try those. If you have issues with this, shoot me an email, and the homework and notes are all posted in Google Classroom.